Today we're going to go over how to create a choropleth using Python. A choropleth is a type of image where the colors represent relative values of a variable. Here's different examples of choropleths for maps. You could also have choropleths overlaid onto your own image. We're going to show this using our legacy version of the platform just because it's a lot easier. So to find this example, you can go to our CrossCompute.com, click on Run Old Tools, find my name. There's two names, one with 11 stars and one with 1 star. Let's pick the one with 11 stars and you should find it among the tools. Represent values using colors in an image. So first we'll show how this tool works. We'll run it a couple times and then we'll work through the code. So what this takes as input is it takes a template image where you have different unique colors that you want to replace, and then it takes different values of a variable. The name here doesn't actually matter. It's the sequence of rows here that get matched to the colors. You pick a color map, let's say blues. Let's update these colors a bit. And just put here, so we should expect to see a right arm and left leg 3, and we choose a default color for the, in case the value of the variable is 0. So when you run it, you're going to get a color histogram representing the distribution of colors in the original image, and then the remapped choropleth representing the values of your variable. So let's try this another time. We'll make our own image using Gimp. Gimp is a free program that you can download. And let's draw our own picture. Let's make a happy sun. And let's add a tree. We will make it like a palm tree, maybe. Some leaves. So make sure, note that we're using the pencil tool, not the paintbrush. The pencil will generate strokes with very clear edges. The paintbrush will create these interpolated colors with lots of shades, and that's going to make the color replacement difficult. So just try to make sure you use the pencil tool. And finally, let's add some, I guess we could add an ocean here. If you make some mistakes, it's okay. Just forgive yourself. We're just having fun. All right, an image, zealous crop, and let's export it. We'll call it Island Oasis. All right, so note how many colors we used. 1, 2, 3, 4. 4 colors and a background. So let's upload that. Okay, it's not showing, but that's okay. And I don't know, I think we had a sun. So just forward that to 2. And some leaves. The order, we might have to run this a couple times to get the order right. trunk, ocean, 7 there. And some other stuff that we're not going to use. And we'll use the, which color map should we use? Maybe oranges. And the default color for 0 we'll put as white. There's our image. See what it comes up. So our color distribution, this is showing us that 0 is green, which means the leaves are actually the first one. And we have the ocean, the trunk, and the sun, and then the background. Knowing this, let's redistribute our values. So let's say we want oranges. Let's say we want the leaves to be the maximum orange, ocean to be a little bit, trunk to be a little bit. We'll make the sun the maximum orange. Rerun this. So we created a map. So how does this work? So let's take a look at the notebook. You just clicked on the notebook. And let's run it. Okay, so like I said, this is the legacy version. It's a couple years old of the platform. We'll probably update this to Jupyter Lab. So how does this work? So remember our input variables. We have a source image, we have table of parts, we have the color map that was selected, and the name for the color when it's 0. So first we open the image, and image, this mode, the default mode is red, green, blue, RGB. And we'll just kind of show everything here. Just clear all the outputs first. So our original image is, these are the dimensions of it. You can see the 3 bands. 382, so 382 is probably the number of rows, and 340 is the width, and then 3 bands for the colors. So what we're going to do, we're using this Stack Overflow article on how to get the unique. So how did we get the color distribution of the image? We used, first we'll reshape our image. So -1 is a handy way to let the reshape function know that you want to have reshape function figure out what the dimensions should be. So our image array was originally a 3-dimensional array. So these are the 2 dimensions and with 3 bands. So here there's 3 dimensions here, 1, 2, 3. We're telling it to reduce it to 2 dimensions by specifying 2 arguments. And the second dimension should have 3 bands and say reshape this array into a 2-dimensional array where the last dimension has 3 bands, and figure out what how big it should be. So that's what it means. And when you do it, it's just, you can see it multiplied got these together. So what we have here is a list of colors. You can see some of the colors here in the color array. So let's get the first three. So these are, most of the colors are white, so that's what this is. Could try looking at a couple more. Still white. Maybe if you sort it, let's see some other types of colors. If we can sort it. Yeah, well, this looks like green. So red, green, blue. All right, so let's get the number of unique colors. There are 7 colors in this image. We're using NP unique with return counts true along one of the axes. And let's just plot the colors. You can see we using the imshow function. So to plot our histogram, we're just taking the counts from unique and using bar. This is the legacy version of the platform, so you have to print the values, and the name here matters. This was what causes the table to be printed in the tool. But to go back to Python, we load the part table. We load our color map. So color map, what it is it maps values from 0 to 1 into a color map that's also from 0 to 1. So, and because our image is a 8-bit image, we need the colors to vary from 0 to 256. So we scale this color map, and there's a lot of color maps available. You could look at the full list with plot color maps. Okay, and the part that needs the most explanation is this part. So what we do is we take the original image, we take the transpose of it, which changes the shape so that we can extract the 3 bands separately. So now we have, for example, the red band, which is just the red component of the image. And given a specific color, what we can do is find the parts of the image where the red value matches, the green value matches, and the blue value matches. So this just means which parts of the image is matching our target color. So let's say our target color is green, that Boolean mask will return true on this area. So this color area is a Boolean mask, and we apply this Boolean mask of where it's true, and for those parts of the image, we set our new color with a value ranging from 0 to 255 because it's an 8-bit image. And the format that we use for the array is we don't have an alpha band here. So you can see the old array and the new array where the torso has been replaced. And that was the reason the torso has been replaced is because we chose as our color the first color, which happens to be blue, and the torso was blue. So for the final loop, what we do, and we use 2RGB to convert the color name or hex name to also an RGB color. So to expand this in a loop, and this is also taken from another Stack Overflow part, that gives these tips. So what we do is we iterate through the parts table and the colors where each row of the part is lined up with the colors in order from here in this sequence. we normalize the score so that it varies from 0 through 1. So if the normalized score is defined, we use a part from the color map. Otherwise, we use our 0 color default. And here's where we overwrite that part of the image with our color. And we generate our image, and we save it. So this, if you want to fiddle with it, you can click the blue button to preview the tool. And you could change the way it works. Okay, so that's our small little tutorial today on image representation in Python and NumPy. And subscribe for more.